Week 9, Lesson 5. Okay, so if you take a look at this graph that was given, you can kind of see that over here to the right, we are going to be graphing something that's really similar to it, but not exactly the same. All right, and again, take a look at the one to the far right. Again, similar, but not exactly the same. So each of these has a particular pattern that kind of goes with it. So let's take a look at the first one. Let's analyze this down here. Okay, so if you're given the original graph, which you are, and you're asked to graph the absolute value of it, which you can see right here, that's what you're being asked to graph. It says, again, you can read, but that it is unchanged for y is greater than or equal to 0, which means that this part of the graph and this part of the graph are unchanged. So let me just take a moment and transfer those parts over here. So at -2, 0, I still have a dot. At -1.1 something or other, I'm up here at 3 point something. Again, this is a close approximation, 0, 0. So this part is still here. And then from 2, 0, it continues up. Okay, so that part is unchanged. Okay, but then, again, if you continue to read on here, it says, and for y is less than 0, it's reflected across the x-axis, which means this part's in blue. Oh, wait, that's not a highlighter. This part down here in blue and this part in here in blue, those get reflected over the x-axis. So let me switch to blue. That means this part down here now looks like this. And this part that's sort of a downward bump ends up being an upward bump. So that is what the graph looks like for the absolute value of the entire function. Okay? To graph this one, okay, which you can see down here is actually f of the absolute value of x. So we're not taking the absolute value of the entire thing, just the x values itself. It says that the graph is unchanged where x is greater than 0. In other words, this part, right? All of that where x is greater than 0 is unchanged. So let me transfer that over. We've got this. There's a point way down here, right about there, and this, and it keeps going up. Okay, so that part is unchanged. Okay, but the part that does change is over here. Where x is less than 0, you're going to take this part that I just graphed in blue, and you're going to reflect it. Oh, that's the wrong pen. So I'm going to reflect this part over the y-axis, and you'll get this graph. All right, so let me scoot this up. Let's try. I've got a couple more examples. Okay, so for this example, they don't give us the original graph. So they're going to, you are expected to be able to graph this parabola. So let's do that. It has a vertex at 2, -4. 1, 2, 3. Right there's its vertex. Over 1 and up 1. Over 2 and up 4. Over 3 and up 9. 5, 6, 7, 8, 9. Okay, so here is our original. Okay, so to graph, and I'll try to highlight for you, to graph this one that's in pink, I have to keep the stuff that is above the x-axis the same. Every time I forget to switch pens. So the stuff that's 1, 2, 3, that's above the x-axis, this and this remains the same. And the stuff that's below the x-axis gets reflected over the x-axis. So I'll have that point and that point and that point reflected over, right? All the stuff that used to be down here is now reflected up. Okay, now let me switch colors. So this one in blue, notice the notation, it's just the absolute value of x, which means that all the points that were to the every flippin' time, you guys, so frustrating. All the stuff that's over here to the right of the x-axis, I think it's that point right there. All this remains unchanged. All the positive values of x remain unchanged. And then once you've graphed that, you just reflect it over the y-axis to get the other part. So that and that and that and 1, 2, 3, 4. I'm pretty sure it's that. And you get that picture. Okay, let me scoot this up. I think I have 2 more examples. Okay, so for this one, if you remember graphing rational functions, we did it earlier in either week 8 or week 9, can't remember. But this has an asymptote, a vertical one at 2, and it has a horizontal one at 1. And if you make a little XY chart to get at least a couple of ordered pairs, right? Maybe 1 and 3 and 4 and 5. But that's what the original looks like. Okay, so to graph this one here in pink, everything that is above the x-axis remains the same. So if it's on the x-axis, that's fine. Every time, you guys, it's almost like a prediction. This remains the same. The asymptote will remain the same. That asymptote will remain the same. These ordered pairs will remain the same. Right? But what happens here is this point gets reflected up. I'm pretty sure I had another ordered pair right here at -1. That becomes +1, so it kind of does this. Okay. Again, notice that when you take the absolute value, you end up with nothing down here in the negative area, right? It kind of makes sense. The y values are all going to be positive. No matter what you plug in, it has to come out to be positive. Okay, so now this one, which I think I'm going to do in red. Okay, this one, the stuff that is to the right of the y-axis remains the same. So this ordered pairs every time. You guys should really just be laughing because I'm getting tired and can't do this much longer. Okay, hold on, I just screwed that point up. That should be at -1/2. That should be at -1. Here's an asymptote. All right, and then there's an asymptote over here. Over here, I've got some ordered pairs. I believe this one's at 2.5 and 2. Okay, so that stuff remains the same. And now I just have to reflect it over. So now I'm going to have an asymptote over here at -2. This is going to reflect over. This is going to have a point here and a point there and there. Again, just a reflection over the y-axis. All right, so then let me scoot this up for the last example. Okay, a couple things I want you to notice on here. So here, the original function is a line with a y-intercept of -3 and a slope of 2. Okay, now notice the notation here. Okay, it's slightly different than the last ones, but I want you to notice this says take the absolute value of the entire function, where this one says take the absolute value of x. Okay, absolute value of the entire function means that all the stuff that is below the x-axis will get reflected up. So let me sort of keep what was there. 3, slope of 2. So this is the stuff that was above, and now I just have to reflect it over. Okay, and then the other one, it's everything that's to the right of the y-axis. So here's this part, and when I reflect it over, you end up with that picture.